Question 11, Part E. Solve cos theta plus sin theta equals 1 for theta greater than or equal to 0 and less than or equal to 2 pi. Solving an equation involving the sum of two different trigonometric terms equaling a non-zero constant is generally more difficult than solving a trigonometric equation involving one trigonometric term equaling a non-zero constant. So the first step is to express cos theta plus sin theta in the form r sin theta plus or minus alpha. We could have used r cos theta plus or minus alpha as well, but I've chosen r sin theta plus alpha because later on I'm going to expand r sin theta plus alpha and then equate coefficients. And this form here generally lends itself well given the nature of the expression that we're dealing with, which is cos theta plus sin theta. If it was cos theta minus sin theta, I would probably use r sin theta minus alpha. The reason why I prefer to use sine rather than cos in this case is the expansion of sine. So let's say sine A plus B. It's going to be sine A cos B plus cos B sine A. So we don't change the sign when going from here to the expansion. So expanding r sine theta plus alpha, we get r sine theta cos alpha plus r sine alpha cos theta is equivalent to this expression here. In other words, it's equivalent to sine theta plus cos theta. Notice that I've switched the terms around and addition is commutative, so we can do that. And the reason for that is I'm going to equate the coefficient of this sine theta with the coefficient of this sine theta here. Now the coefficient of this sine theta is r cos alpha, and the coefficient of this sine theta here is 1. So r cos alpha equals 1. And I've called that equation number 1. Equating the coefficient of cos theta here with the coefficient of cos theta here, for the same reason, r sine alpha is equal to 1. And I've written that equation here, and I've called that equation number 2. So we have equation 1 here, equation 2 here. We have a pair of simultaneous equations that we can now solve to find the value of r and to find the value of the auxiliary angle alpha. Notice that both of these values here, 1 and 1, are positive, which implies that the angle alpha is in quadrant 1. Next, let's find the value of r by squaring both equations and adding them together. And in doing so, we end up creating a cos squared alpha and a sine squared alpha. And we can use a very handy Pythagorean identity, that is cos squared alpha plus sine squared alpha equals 1, to eliminate the trigonometric terms, and then we're just left with r squared, which obviously we can then use to find r. So equation 1 squared plus equation 2 squared is equal to r squared cos squared alpha plus r squared sine squared alpha, which equals 1 squared plus 1 squared. Now 1 squared plus 1 squared is equal to 2. Factorising out r squared from both of these terms, we get r squared outside of cos squared alpha plus sine squared alpha in brackets. And cos squared alpha plus sine squared alpha is equal to 1. So r squared is equal to 2. Hence r is equal to the square root of 2. Now r represents an amplitude, so it needs to be positive, which is why we don't use negative square root of 2. Next, we'll find the value of the auxiliary angle, and we do that by taking equation number 2 and dividing it by equation number 1, which eliminates the r term, and sine alpha divided by cos alpha is equivalent to tan alpha. So tan alpha equals 1, taking inverse tan of both sides, we get alpha is equal to pi over 4. Now we can proceed to solve the equation. So we need to solve the square root of 2 times sine of theta plus pi over 4 equals 1, where theta is an angle between 0 and 2 pi, inclusive of the endpoints. Dividing both sides of the equation by the square root of 2, we get sine theta plus pi over 4 is equal to 1 over the square root of 2, or root 2 over 2. Taking the inverse sine of both sides, we get theta plus pi over 4 is equal to pi over 4, that's a quadrant 1 angle. 3 pi over 4, which is a quadrant 2 angle, since this is positive, and 9 pi over 4. Now that's a value that's greater than 2 pi, but it sits in quadrant 1. So it's like gone around the circle once, and then gone a further pi over 4. So that's why we get this 9 pi over 4. And again, thinking ahead, I know I have to subtract pi over 4 later on. So I want to make sure that I get every solution possible. So subtracting pi over 4 to make theta the subject from these three values, we end up with theta equals 0, pi over 2, and 2 pi.